In this lecture, I would like to talk about actual adaptation to sea level rise, learning from subsidence in small islands and coastal megacities. And this keynote speech will be given by actually three people: myself at Waseda University in Japan, Laurice Yamero at Manila Observatory in the Philippines, and Christopher Chadwick at Liverpool John Moores University in the UK. But also I'd like to acknowledge that this is collaboration work between many researchers and many universities, so I hope I haven't forgotten anybody in this slide. In this research, we're looking about how cases of land subsidence around the planet can help us understand how adaptation to sea level rise will actually work. And in this lecture, I'm going to be talking about case studies in Jakarta, Tokyo, the phases of adaptation in these cities, the cost of adaptation. Then I will also be talking about how ports can adapt to sea level rise in Jakarta and Tohoku. And then the co-speakers in this will all be talking about a case study of a small island, of a small group of islands in the Philippines. The case study of Jakarta. Well, Jakarta has been subsiding by about 10 to 20 centimeters per year due to a groundwater extraction in the course of the 20th and 21st century. And this graph shows you how other cities in the Asia-Pacific region have subsided or are also subsiding because of this phenomenon. Tokyo subsided by about 4 meters in the course of the 20th century before they stopped groundwater extraction, and this was stopped. Our study site, this is Jakarta, northern Jakarta. This is the area of fluid, and I'll also be talking about some of the ports situated in Jakarta later. In the area of fluid has been experiencing land subsidence. As a consequence, the government have been slowly raising this concrete wall that you can see here. Here you can see in 2007, during the floodings that took place, how water went into the area. But nowadays this small concrete wall has become a rather tall concrete wall. You can see it here. It's much higher than a human being. It's about 2 meters high last time we went. And that's the only thing that's preventing the water from entering and flooding the place. Here on the outside, you can see a second dike that is being built further into the water to protect the inhabitants. The case study of Tokyo, as I said before, it's subsided by about 4 meters. The area also suffers from typhoons, and in 1917 there was substantial flooding in Tokyo by a storm surge that was over 3 meters in height. As a consequence, they've built dikes all around Tokyo. This is one of the areas, and it shows you the height of the dike, and this pole shows you the storm surge levels of 3 famous typhoons, and also it shows you the high water level. So at high tide the water would be this high. So if the dikes were to fail, things would be flooded to houses would be flooded to the first or second floor depending on the area. Here you can see what some of the dikes or levees in this case look like, and if they were to fail, all these houses would be flooded. What's the adaptation sequence in Tokyo and Jakarta? How they adapted historically? They both started by building these little concrete dikes, concrete walls really we should call them. In the case of Tokyo, it was a small one, looks remarkably similar to the one of Jakarta. And even places like Miami started a similar approach. Then you need to start building pumps to remove the excess water. So Tokyo built pumps, Jakarta built pumps, and Miami has also started to build pumps. Although these are for rainwater, but still. After that, you need to start reinforcing your levees, constructing storm surge gates. In the case of Tokyo, there's a storm surge gate. In the case of Jakarta, they're starting to create better hydraulic measures to channel the water around the city. After that, people, instead of retreating, they actually go into the sea. In the case of Tokyo, you have many artificial islands, such as that on Odaiba. Haneda Airport is on an artificial island. And the photo on the left shows you Kasai Rinkai Park. In the case of Jakarta, also, they start to go into the sea. Pelangi Island is shown here, reclaimed with expensive apartments. Also, they're talking about the Great Garuda project. And you can then elevate entire districts. In the case of Tokyo, you have these super-levee projects where you elevate an entire area and rebuild on top of it. And Tohoku in northern Japan has also been extensively raised. I will be talking about this later. The cost of adaptation. we calculated how much would this cost. So how much would it cost to raise the levels of the dikes? Here you can see in different colors in different areas of Tokyo the dikes. How much would it cost to elevate the coastal areas outside of the dikes, port areas that you can't really leave behind the dikes? And all this would be about, let's say, $3 to $4 billion. So it's a lot of money, but in the grand scheme of things, over 100 years, it could easily be done. Not that this doesn't include the cost of rebuilding a building on top of these structures or whatnot. But anyway, these get rebuilt every 30, 40 years in Japan, so the cost. As a consequence of the 2011 Tohoku earthquake, areas in northern Japan subsided by about 0.5 to 1 meters. Of course, there was also a tsunami that destroyed many of the installations. At high tide, what started to happen is the areas became flooded, and what they did was pile some gravel and resurface the port. A different area, the car park, was flooded. Again, they piled some sand and again started to resurface later. So this is a clear indication of how people will adapt ports to 0.5 to 1 meter of sea level rise. Is it possible to raise the areas by even more? Yes. As a tsunami countermeasure, they have raised the land of entire villages by up to 50 meters. And here in the bottom figure, you can see some people. And this town has been raised by 50 meters, as said. And this has happened along hundreds of kilometers of the coastline. The elevation depends on the elevation of the town and tsunami models, but you can see that if you have the money, it's possible to do something like this. Kirikiri, one of our case study sites, also was elevated. So in some cases, the village was elevated in some areas by 10 meters. And they built a much bigger dike in front of certain low-lying parts of the village. Here you can see the dike being built, and in the distance you can see the village already with buildings. What happens to the ports outside of dikes? In Jakarta, they started by building small curbs to keep the water out in Sunda Kelapa port. And this is again Sunda Kelapa port in front of the photo in the previous slide. They're building a bigger dike. And this dike that was smaller in the previous photo is now being raised more to compensate for the ongoing land subsidence. This is the oldest port in Jakarta. Subsidence is 7 to 10 centimeters per year, and what they're doing is adapting by sequences. So the newer part, this part of the port, they're just raising the curve. Eventually, when this becomes too much, they resurface the entire thing and make it look better. They're spending 20% of their income on this adaptation. And to do that, as I said before, what they're doing is, yes, sheet piles, any fill material they get, and then on top they resurface using concrete. Here you can see the newer part of the port. Well, this is some of the old buildings. You can see the water infiltrating, but this area here with the containers is the newly raised port. The port doesn't see that there is a limit of how far they can use using this technology. It's very simple, sheet piles and concreting. And they will just, if it continues to happen, then the government will just have to continue to pay. And they say that even if the ground subsides by 8 meters, they see no limits, no technological, cost benefit, financial or social barrier limits. Another port in Jakarta, Nizam Saham port, they're having the same problem. They tried planting some mangroves in these areas that were below water level. Also, they're building a second dike further out now. And again, it's an old port, subsiding 7-10 centimeters per year. They raised it in 2002, last time in 2012 by 1.4 meters. And here, this section that you can see here, it still hasn't been raised properly, but this and the lower one is the one that's been raised. And this has been done sequentially, as in the previous case. How they're doing? Again, sheet piles and fill. And they see no technological, financial or social barrier limits. But they say, maybe will it be better just to move to a floating port? Muara Angke port, another port in the Philippines. Again, subsidence, in this case about 7 centimeters per year. They've raised it 3 times, 2006, 11 and 14. And next slide is going to show you this sequence. So what you can see here is the last time they elevated this part of the port. So here you can see some of the newly reclaimed areas, very nice and beautiful with expensive apartments. And here you can see the entire sequence. The first elevation is now underwater. The second one So this is all underwater, and the second one you can see here, and the third one to the right. So this is essentially how it will look. Again, sheet piles and fill. They see no technological, cost-benefit, financial or social barrier limits up to about 1 meter. And after that, they think maybe it should be better just to move to a floating port. And they've already started experimenting with that. And here you can see the floating structures that they've started to design. Tohoku and land subsidence. In the case of Tohoku, things are more complicated. And of course, you have to consider about tsunamis and earthquake measures. And this is the problem. As an earthquake countermeasure, to raise the port, you need to use all these big piles. Here, they say that there are no technological limits, cost-benefit limits, financial barriers or social barriers up to about 2 to 4 meters of subsidence, but eventually things will become expensive, and after about 4 meters, maybe local residents would be happier for them to retreat rather than to be spending more and more money on this. Kamaishi Port, we looked at another place in northern Japan. We found out some costs. They're substantial, but if you don't have to take into account earthquake countermeasures, it's viable. If you do, then things become more complicated. And in the next few slides, my co-speakers will talk about adaptation in small islands.
To help us appreciate what sea level rise really means for island communities, allow me to share with you the experiences of the small island communities in Tubigon, which is a municipality located in the northeastern side of Bohol. Specifically, I'm going to talk about 4 small islands, Bilang-Bilangan, Pangapasan, Ubay, and Batasan. As you recall, in October 2013, there was a 7.2 magnitude earthquake in Bohol, which induced land subsidence in these islands. As a result, these islands now become flooded even during normal high tides, which they rarely experienced before the earthquake. Of course, this morning we are talking about climate-induced sea level rise, but what our research team did was to build an analogy using earthquake-induced land subsidence to better understand specifically the flooding impacts of climate-induced sea level rise, for which we currently lack case studies.
Daghan kayo mga problema nga among ma-encounter bitaw kada taob jud. Kung magtudlo man gud ni unya taob, ang attention sa mga bata wala na gyud naa na gyud sa dagat. Ang mga bata physically kanang present but mentally absent kay they are looking at you, magtan-aw sila nimo pero ang ilang mga tiil magana magkasaw-kasaw nya. Aside niya na sad kaning hugaw. Kaya unta kung isda bitaw ang muso dinhi sa kanang classroom, but ang nakapait manggod kung ang musod, manure na, hugaw na sa tao. It's no longer safe to live in an island like this, especially during high tides. Then, mas worst pa jud kung high tides plus kanang typhoon, mao ginay pinakapeligro. Gi-envision ako nga unta na ay lain galing organization nga mutabang gali namo mo suporta nga bisa na lang og ma-elevate ning amo ang classroom kay para panahon sa taob dili na kaayo may mapektuhan.
Communities talk about adaptation, they often get asked, how long can you keep doing what you're doing now? What is the limit of adaptation? This is how many people typically understand adaptation. They think that after a certain tipping point, let's say 1 or 2 meters of sea level rise, then island communities will no longer have a choice but to retreat to the mainland. However, there are several challenges to this current understanding. First, the tipping point is usually expressed as an environmental factor, although we already know for a fact that people move away from their homes for many reasons, including social and economic. And at the same time, in this framing, retreat is often portrayed as a failure of in situ adaptation. There are many other potential limiting factors that are being hypothesized in existing literature to drive mass migration. These include the physical survival of the islands, tidal flood height and frequency, the cost of adaptation, and even extreme events. However, in the experience of the islands of Tubigon, these potential limiting factors determine the level of adaptation and not the limit itself. Instead, there are two potential limiting factors that may apply in the experience of the islands of Tubigon, and these are development problems and the future outlook of communities. In Tubigon, although the island communities already experience severe tidal flooding, they are still more concerned about poverty and the lack of livelihood options in the islands, and this can be problematic because development directly relates to adaptive capacity. And at the same time, how the islanders perceive their future on the islands could affect their decision to stay or to leave. But this is not so much about scaring the island communities until finally they decide to move. It's more about painting a more positive outlook for them on the mainland, which the municipal government is currently doing through providing scholarships to students until college, and at the same time ensuring that young islanders have skills that are employable in the mainland. So what are the key takeaways for us? First, we should stop thinking of adaptation as a matter of tipping points, but rather as a matter of choice. Island communities should be able to choose whether they want to adapt via in situ strategies or retreat strategies, or a combination of both. But to be able to make this choice, they should have at least three of these things. First, sustainable development, which will help them build their adaptive capacity. They should also have full knowledge of their available adaptation options. And lastly, a proper understanding of the risks that they face in staying as well as in leaving the islands. We should also take control of the narrative and shift away from sinking islands to resilient islands. We should stop thinking of island communities as a basket case and force them to relocate when they aren't ready yet, and rather start to recognize how resilience has always been part of the island life. Thank you.
So what are the conclusions that we can obtain from all this work? Well, one of the takeaways that I would like you to think about is that as coastal engineers, we really need to understand the reality of coastal adaptation and how this takes place. Many people are talking in hypotheticals about what will happen, whether people will retreat or not. But from what I've seen so far in places like Jakarta, Tokyo, Miami, Ho Chi Minh City, other places from Manila, people are not going to migrate, and especially not just because they get their feet wet. So as you've seen from the example of these islands, people are still there despite the fact that their feet are wet. So we're probably not going to retreat from coastal areas due to sea level rise alone. I want to say that tsunamis and typhoons might cause different outcomes, but sea level rise alone is unlikely to make any cities retreat. Adaptation is sequential, and no significant barriers were identified by port authorities. Essentially, just because you get a sea level rise of 1 meter, the port is not going to relocate, and it can continue to adapt even for 2 meters, even more probably. If anything, what you can see from modern cities around the planet is that people are going to advance on the sea rather than retreat. More and more areas are reclaimed from the sea. This is not, I don't want you to think that I'm saying that there is no problem. No, there is a big problem. All this is going to be hugely expensive, and it's going to be, somebody's going to have to pay for all this adaptation, and the effects will be felt disproportionately by the poorer people who often inhabit the areas most at risk. So it's a big problem. The question is who is going to pay for it, and how are we going to go on about it in the course of the 21st century. Thank you for listening. If you have any questions, please feel free to send any of us an email.